I'm doing well, thank you. How are all of you?
We're doing fine. The kids are excited to have you with us. Thank you for accepting our invitation.
Absolutely, yeah, I'm very excited to be here with all of you as well.
Right. I hope today is going to be a really fun session. So students, make sure that you all be in the session throughout because Miss Jenny has a lot to share with us. So before we start, I would also like to thank our director, Wendy, Miss Wendy, for organizing this because it's thanks to her that we are able to do this. So yes, Miss Jenny, it's over to you. Please carry on.
Okay, wonderful. I will go ahead and share my screen and then hopefully you all will be able to see that with me. Oh, it looks like you need to give me permission to share my screen.
Sorry about that.
No worries. There we go. Okay. And then let me just make it so that I can see all of you as well, so that I can see if anyone has any questions throughout this. Okay, great. Can you see my slides okay?
Yes, we can.
Yes.
Wonderful. Thank you. Thank you for confirming that. All right. Well, good evening. I'm really excited to be here with all of you. It's actually very early morning where I am right now.
Good
Ooh, what was that?
Good evening, teacher.
Good evening, teacher.
Hello, good evening. Yes, it is evening where you are. It is morning where I am. Actually, the sun has not come up yet where I am. But I'm very excited that thanks to technology, I'm able to be here with all of you, even though it's evening for all of you and morning for me. So for this evening or for today's talk, I am going to be talking to you about NASA's DART mission, which is the Double Asteroid Redirect Test. We will talk about a few things before that. I know that you all have a wonderful astronomy coach here and you note some information already about astronomy, but we'll make sure that we understand some of the basics before we talk about what is NASA's DART mission and what did they try to do with that Double Asteroid Redirect Test. But quickly, I do want to just let you know who I am. So my name is Jennie King. Sometimes I go by Jennie Star Stuff because I'm always thinking about star stuff. But you can just call me Jennie or whatever you want to call me. And I'm a NASA Solar System Ambassador. When I am not talking about astronomy and space science with wonderful students like yourselves, some other things that I enjoy are reading, singing, and then spending time with my cat whose name is Kepler. So you can see a picture of Kepler on this slide there as well. So throughout today's talk, there are a few different ways that you can participate along with me. One is that, of course, if you want to type questions in the chat, I should be able to see that. You can, of course, also use that raising hand feature in Zoom, or just let me know when you have a question. I might not be looking at the chat the whole time, but I will try to check in to make sure that everyone is understanding what's happening throughout the talk. And there will also be some opportunities for you to participate if you have some paper and a pencil or something to write with. There will be some activities where you may want to write something or even draw something. I will ask you at one point if you're willing to do a little design activity where you imagine your own space mission. So I'll be very excited to see what you come up with for that. So today I will be talking first about asteroids, and then other solar system objects that often get confused for asteroids. So things like comets, meteors, meteorites. You may already be an expert on these things, but because I've never met you before, I do want to make sure that we all have common definitions for what all of these different space objects are. Once we better understand all of those objects, then we will finally talk about NASA's DART mission, which was the first ever planetary defense mission, where NASA crashed a spacecraft into an asteroid on purpose to see if it was possible to move that asteroid. It's a very exciting mission. The crashing into the asteroid part happened just a few months ago. That was earlier this year. So once we understand everything about asteroids and other solar system objects, we will end by talking all about that DART mission. So first, I want to show you a picture of an asteroid, and then I just want to ask to see if any of you know already. Does anybody know what an asteroid is? Feel free to answer if you think you know.
It's a moon rock.
Ooh, very good guess. Yeah, that looks a lot like a moon rock. Awesome. Any other thoughts?
When asteroids come crashing down, it gets heated.
Yeah, so pieces of asteroids can come crashing down. Actually, NASA's DART mission is all about trying to stop an asteroid from crashing down. So that's true. So this picture that I'm showing you on this slide here, this is a very large asteroid. This is one of the biggest ones. Its name is Vesta, and this is an asteroid that was visited back in 2011 and 2012 by a different spacecraft called Dawn. Vesta is a very large asteroid. The asteroid that NASA's DART mission hit was much smaller than this, but as we'll talk about a little bit later, small objects moving very quickly can still make very big impacts when they hit a planet. So that is one of the things that we'll want to understand so that we know exactly what was the DART mission trying to do. Why did it want to crash into an asteroid? So asteroids are smaller than a planet. So I know one of you mentioned that it's something like a moon rock. They are smaller than planets, but they are larger than some other objects, the objects that we call meteoroids. We'll talk about meteoroids briefly in a few minutes as well, because it will be important to understand the differences between all of these different types of objects. Most of the asteroids in our solar system are located in an area that we call the asteroid belt. And the asteroid belt is a region of space between Mars and Jupiter. So asteroids orbit the sun. What was that?
Teacher,
Yes.
in the asteroid belt, when it gets near Neptune, because the asteroid gets pulled.
Ooh, will it get near Neptune? There are some asteroids that might have orbits that take them out that far. Most of them, though, are going to be in this area between Mars and Jupiter, and then some of them get close to Earth. I think objects that would come close to Neptune, that might be something more like a comet. So we'll talk about the difference between asteroids and comets. A comet would be much more likely to have this orbit that takes it all the way out to Neptune. Very good question, though. So asteroids are orbiting the sun. Most of their orbits are in this area between Mars and Jupiter, like you can see in this picture here. But there are some asteroids that do, like I said, come close to our planet, and we call those near-Earth asteroids, which makes sense because they come near the Earth. And that will be important when we talk about what did the DART mission do and what did it accomplish earlier this year. So sometimes asteroids can crash into each other when they're moving around in space. And sometimes when they crash into each other, pieces fall off of them. The smaller pieces that break off of asteroids, those are called meteoroids. Meteoroids also can come from another type of space object. So one object they can come from is asteroids. Does anybody know another object in space that could cause a meteoroid to form?
A comet?
Exactly. I just gave you a little hint on that one. You're absolutely right. So meteoroids can also break off of things like comets, which are sometimes even much, much larger than most asteroids. So let's talk quickly about comets. Now, again, I know some of you already may know the difference between these, but when we understand the differences and we all have the same definitions, again, we can know why are we most worried about protecting the Earth from asteroids?
Because if the asteroids hit the Earth's surface, it could cause some kind of extinction like it did to the dinosaurs.
Yeah, so that's really, really wonderful that you know about what happened when the dinosaurs had an extinction caused by a very large object from space. A little bit later, I will actually show a picture of that impact site in Chicxulub, Mexico, where that asteroid is thought to have hit that caused that extinction. And then I'll also give you some good news, which is that we're not too worried about an object that big hitting the Earth. Astronomers know where those objects are. So that's some good news to talk about, but there are still many, many smaller ones.
They say that some kind of meteor that could cause a big extinction like that is very rare in space.
Yes, that's correct. It is very rare. And like I said, we have scientists who spend their entire careers looking at tracking those
Teacher?
objects.
Teacher,
Yes.
the comets are in the Kuiper Belt, no?
Oh, and the Kuiper Belt. Yeah, so comets can take their orbits through the Kuiper Belt. They can also sometimes be found in an area even further away from the Kuiper Belt called the Oort cloud. If you've ever heard of the Oort cloud, that's even further out in our solar system beyond the Kuiper Belt. And that's where lots of comets' orbits go. And then they sometimes come in towards the sun. So comets do orbit the sun, just like asteroids, but comets are made mostly of things like ice and dust instead of being made mostly of rock, like
Teacher?
asteroids do. Yes.
The comets are made from ice from Saturn?
They may be made of some similar ices to what you might find in that area. And in fact, some of Saturn's moons have, and one moon in particular called Enceladus, if you've heard of that one, that's actually one of my favorite moons, that has actual water on it. So water ice and liquid water coming off of it. And a lot of people hypothesize that comets could have even carried water to Earth at one point in history. Yeah, so it sounds like you've heard of that before.
When a comet crashed, they give us water and gold and silver.
Yeah, so it is possible that not only materials fall off of comets, but yeah, it could actually bring water to different places in the solar system as well. And that's because if you look at this picture of the comet, right, when they come close to the sun, that ice and dust that makes up the comet, those can start to vaporize. And that vaporizing ice and dust from getting so close to the sun, that's what causes this beautiful tail that you see that is coming off of a comet. You can actually sometimes see a comet in the sky even when it's really far away from Earth, right? And that's because of that large bright tail that you get when it comes close to the sun. So when a comet's far away from the sun, it doesn't look that different from an asteroid. It just looks like, you know, a big combination of ice and dust and some rock that's floating around. But when it gets close to the sun, that's where it starts looking very interesting. Okay, one of the other terms that we need to make sure we know the difference between, that's meteors. And these are terms that even adults sometimes confuse, right? Because we talked about meteoroids, then there's meteors, and that's a totally different thing, right? So that's what happens when sometimes meteoroids get close enough to touch Earth's atmosphere and enter Earth's atmosphere. If a meteoroid comes close enough to Earth and enters the atmosphere, it can vaporize and it turns into a meteor. The meteor is the name that we give to this bright streak of light in the sky. And because of their appearance, sometimes people call these streaks of light shooting stars. But as I'm sure you all know, as astronomy students, they're not actually stars. That would be very scary, right? If a star was actually going through the sky going through our atmosphere, that would be pretty scary. So luckily, most of these are very, very small pieces of material, and they're burning up in the atmosphere before they even touch the ground. Sometimes, because they leave those streaks of light in the sky, people actually confuse these with comets. But a meteor, of course, is also very different from a comet. It's much smaller, and it's usually harmless and doesn't reach the surface, because that bright light that you see again is the light coming off of it while it is vaporizing. Okay, now here's a question for you. I'm curious, since you probably know what meteors are, have any of you ever seen a meteor shower before, where there are lots of meteors in the sky? Has anybody ever seen this before?
No.
No.
Ooh, so it's a very exciting thing to see. I'll talk a little bit about how you can see the most meteors if this ever happens. And then maybe what I can do after today's talk is I can actually send a list along to your teachers who can give this out to you and show you which meteor showers might be easiest to see from your part in the world. Maybe a calendar of the meteor showers from next year could be very exciting. So meteors are the bright streaks of light in the sky. Meteor showers are what we call it when there are many, many meteors being seen. So if you lay back on the ground, you see lots of meteors flying by over your head all in the same time. Now it's possible you can go outside at any night and see a meteor or a couple of meteors going through the sky. Meteor showers are when there are very many, and I think they're a very beautiful thing to witness. So the best way to watch a meteor shower is to find a good place at night where you can have a very clear view of the sky, and then to lie down on the ground and watch the sky above you. A lot of people have asked me, should I try to find a telescope to look at a meteor shower? And my answer to that is no, you actually do not want something like a telescope for a meteor shower. You just want your eyes and to see as big an area of the sky as you can. And remember that most of the bright streaks that you would see in a meteor shower are very small particles that are burning up in the atmosphere before they ever reach the ground. And if you look at the picture on the right here, that shows that if you trace the meteors back, they all seem to be coming from one area in the sky. And that's because during a meteor shower, these pieces of material are all hitting the Earth from the same angle. And I see a hand raised. Do you have a question or a comment?
Teacher,
Yes.
does a meteor shower come every day?
Is there a meteor shower coming when? What was the question?
Are meteor showers coming every day?
Oh, that's an excellent question. So they're not coming every day. They happen at certain times during the year. But the good news is we know how to predict them. So that's why sometimes I actually have my personal calendar that I use has meteor showers listed on it. So I can look at the month ahead and I can see, oh, is there a meteor shower happening later on this month? And then you can plan for that. And the reason for that, I'll talk about in a moment, but it looks like someone else has a question. Feel free if you also have a question. I see another hand raised.
Teacher,
Yes.
when the comet goes too far from the Kuiper belt, it deaths.
When it goes too far from the Kuiper belt?
Yes.
And what was there a question?
Sadham, could you repeat the question again if you don't?
What happens if the comet goes too far from the Kuiper belt?
Yes, so there are comets that do get very far away from that area. In fact, this might be a picture that kind of helps answer that question too. So if you think about how Earth goes around the sun not in a perfect circle, but fairly close to a circle, something like a comet. Comets can have these absolutely wild orbits that take them thousands or even millions of years. So comets go very, very far out to the far edges of the solar system, past the Kuiper belt, many of them way out there. When they get out there, they're just very frozen snowballs in space. When they're that far away from the sun, they're not receiving any heat. So it's just a snowball that's very far away from us and we don't have to worry about it. When we see comets and we're able to observe them, it's actually because they're coming in very close to the sun. So like you can see in this picture, comets go very far away in their orbits. Sometimes they're way up, not even in the same direction of orbit as the planets are. And then we see them when they come closer into the sun. And I think there's another question. Go ahead.
When a meteor shower happens, after it finishes, all the meteors hit the Earth's surface. So what kind of, it would not cause a very big damage, no?
That's a really excellent question. So I think the question was about when we're going through all of that debris that's causing a meteor shower, is that damaging the Earth? And the good news is that even though it's a lot of material that's hitting the Earth's atmosphere, it's very, very small. In fact, when I say it's very small, most of the pieces of material in a meteor shower are as big as a grain of sand or a piece of dust. They're very, very small. So when they hit the atmosphere moving so quickly, the vast majority of them burn up before they ever touch the ground. In fact, even when there's not a meteor shower, the Earth is getting hit with lots of material from space all the time. It's happening during the daytime often, and we're not even noticing because, again, most of it is burning up in the atmosphere. And actually, that's a very good question, because my next slide is all about what happens sometimes, rarely compared to the ones that burn up in the atmosphere, but sometimes objects from space, much larger objects, do make it through the atmosphere. They don't burn up like most of those things in a meteor shower, and they actually reach the Earth's surface. And that's when we call an object a meteorite. So like you can see here, right, this is a person standing on the surface of the Earth, and there's a meteorite on the ground. So that's what we call it when much larger objects have the amount of mass that's required to make it all the way through the atmosphere and then touch the ground. One way that I like to remember this, because there are all of these different terms, right? Meteor, meteoroid, and then finally meteorite. I always thought of this growing up as meteorites go right to the ground. They go through and all the way to the ground. So that's a meteorite. Okay. So I just went through a lot of different kinds of space objects, including asteroids, and some that are sometimes confused for asteroids. So let's pause for a moment to summarize our learning so far with a little bit of a game that will require you to write some things down. And this is called What's That Spacerock? So this is where we find out who is an expert already on these different space objects. So if you do have a piece of paper and something to write with, or a notebook, go ahead and grab that notebook or piece of paper and then number it like you see on my picture here. There are going to be 10 pictures of different objects in space. And then I will ask you if you can identify which of the objects I just talked about you're seeing in that picture. So I'll give you a moment. I see lots of papers and notebooks coming out. So feel free to number a piece of paper like this, 1 through 10, and then make sure you leave enough room to just write one word next to each one. Or maybe you can write a few letters to abbreviate, just something so you remember what all of your answers were. I see lots of you still writing, so I'll give you a little bit more time. And then remember, some of these are going to be more difficult than others. These are objects that are very easy to confuse. So some of you may be experts already, but remember, it's all for fun. So just do your best when trying to identify which of these objects there are. And then at the end, I will ask if there are volunteers who want to share how well you did and how many you got correct, but you do not have to share how many you got correct unless you want to. Okay, I think there might still be some pencils moving, so I'll give you just a few more moments. And then we will begin with number 1. All right. It looks like some of you might be done numbering 1 through 10. I'll try to go a little bit slowly at first. All right, looks like we're all ready to go there. Wonderful. I will start with number 1. And if at any time I'm moving too quickly, feel free to just raise your hand and let me know. And then at the end, I'll actually ask if you missed any and you'd like to go back and have one more look before we reveal the answers. So let's see how well we know all of these space rocks before we start talking about what happens when they do enter the Earth's atmosphere and hit the Earth sometimes. Okay. So make sure you're writing your answers. I know you might get excited. Don't share your answers out loud yet, but let's start with number 1 here. Take a look at this picture, and then you have these 5 options in the word bank. So this is a picture of either a comet, a meteor, an asteroid, a meteorite, or a meteoroid? For number one, write down which one you think it is. And I know if you know, you might get excited, but I'm very impressed that you're resisting the urge to unmute and say your answers if you know what it is. We'll do all of the answers at the end. And then if you want to proudly share how you did, you're welcome to do that. So once again, these will be your answers on every picture. Every picture I show you will be a comet or a meteor or an asteroid or a meteorite or a meteoroid. Okay, that was number one. So if you haven't made a guess yet, please choose which one you think it is and write that down for number one. Okay, I am about to move on to number two. Oh, I see a hand up. Yes.
Is it okay if I get it wrong?
Can you repeat that question, please?
Is it okay if I get it wrong?
Oh, yeah, so this is just for fun. It doesn't matter if you get it right or wrong. It's absolutely okay to get it right or wrong. And in fact, when we get things wrong, that's not always bad, right? That's something that I always try to remember in my own learning experiences, is when you get a question wrong, that's sometimes a good thing, because that means you remember the new thing that you learn. When you get something wrong, you're then more motivated to learn more about it. So I've learned over time that it's okay to get things wrong. All right, let's move on to question number two. So this is a picture of another kind of object. And then please choose which one you think it is for number two. Same answer options: comet, meteor, asteroid, meteorite, or meteoroid. I'll give you a moment to think about it and then to write down your answers. And it's completely okay if you don't know. If you're just guessing, just make the best guess that you can. Which one does it look like to you? And like I said, some of them will be a little bit more difficult than others. I tried to use pictures where you can sort of see what it is, but I think some of them are still a bit difficult. Okay, that was number two. I will move on now to number three. So make sure you have your guess in for number two. And now let's take a look.
Can you give me 1 more minute?
Yes, absolutely. I can wait one more moment. Yeah, and thank you for doing that, because I don't know how long it takes to make guesses on all of these. I have all of the answers in front of me, so it takes you a little bit longer. I picked these photos, so I know what they are. You have to actually look at them and think, okay, which one is this? And some of these I'm very excited to talk about. Some of the pictures that I used are objects that I'm excited to tell you a little more detail about when we go over the answers. Okay. Does anybody need a little more time for number two?
Yes, please.
Okay. I wish that there were not 3 answers that all start with M. I would say if you want to just write the first letter, you can, but of course, 3 of these words are very similar. And remember, this isn't something that's being scored or graded for anyone else to look at. This is just for you and for your notes. So please don't be afraid of getting them wrong. Yes?
Okay, I'm done.
Okay, great. Thank you for letting me know. Let's go ahead and move on to number 3. Okay, take a look at that object and then make your guess of which one of these you think it is. And please feel free to just be brave and make a guess. If you're not sure which one it is, or if you don't remember the difference between some of these, that's completely okay. It is just a chance to learn about these things before we move on to talk about space missions related to some of these things. And this is a picture of one that I'm also excited to tell you what it is in the end and discuss this particular object. So your answer choices are the same on all of them.
I have finished answering.
You have finished? Wonderful. Would anyone like a little bit more time on this number 3? Okay, sounds like we might be ready to take a look at number 4. Which type of space rock is this? Now, if you've been paying attention, this is a photo that I've used already in one of the earlier slides.
Showing the arrows.
Yes, so what you are answering is the object that is being pointed out with those arrows, the smaller one, not the large object. And I know this one is a little bit different because the other pictures so far have been actual photographs and this one is a drawing. But that's because this is sort of a hint. That's because this is an object that's a little bit harder to get a photo of because of what it is. So that's why this one is a drawing. You want to answer, what do you think is that smaller broken off piece?
Teacher, I know what is the big piece and the small piece.
Yeah, if you know the big piece and the small piece, that's great. That means you really understand a lot about these different objects. For this question, for number 4, make sure you write down what you think the smaller piece is. Would anyone?
Excuse me, could you go to number 5?
Yes, would anyone like more time on number 4 or are we all ready? Okay, great. Let's move on to number 5 now. Which one is this a picture of? Comet, meteor, asteroid, meteorite, or meteoroid?
Teacher,
Yes.
Karantin, can you tell me the 4th question?
Oh, would you like me to go back to number 4?
Yes, teacher.
Okay, I will quickly go back to number 4 to make sure that you can see that one. So number 4.
I can't see the screen. I can't see the screen.
Oh, you can't see the screen.
Guys, sorry for interrupting. Others, can you all see the screen?
Yes, sir, we could see the screen. I mean, we can see.
Miss Jenny, if you don't mind, could you reshare the screen again?
Oh, yes. Let's see if that helps if one of you can't see it. Okay, so the picture will disappear very quickly. And then it will bring.
It must be that.
Okay, how's that? Are you able to see now? You should hopefully be able to see number 4. I have a little box that says participants can see my screen. Are you able to see it now?
Yes, teacher. Give me a second, teacher.
Okay, wonderful. I'm glad you can see it now. So some of you already have this one, but feel free to check your answer and see if you still agree with what you wrote down for number 4.
Wait a second. Give me 1 second.
Yes, of course. And for any of you that are already finished answering some of these, if you're finished answering the questions a little bit early, you can start thinking about an act. Oh, yes, go ahead.
Excuse me. As I looked at the 5th image, I could see that my first answer was wrong.
Oh, wow. So it's a good thing that we went back to look at it again.
Yeah.
Okay, wonderful. So you actually went back and you looked and you thought, okay, I can correct my answer now. That's great.
Done,
What I was
teacher.
Okay, great. We're ready to move on. What I was going to say is that some of you might be a little bit quicker at making your guesses. And if that's the case, one thing you can think about if you finish early is the activity that we'll do a little bit later in tonight's presentation is thinking about how you would make a spacecraft or a space mission that could move an asteroid. So if you want to start imagining when you have a little bit of time between questions, you can start thinking about how would you move an asteroid in space. You don't have to tell me right now, but you can think about that in advance.
Excuse me, teacher.
Yes.
Can you move to 2? I will find the answer quickly, teacher. I couldn't find it.
You couldn't find the answer?
Yes, teacher.
Okay, the answer is one of these options. So pick which one you think is the best option or the closest option. And then when we show the answers later, we can talk about which one you think it is. Okay, let's move on to number 5. And if you didn't get a chance to look at this one before, we showed this one very quickly. Feel free to write down, what do you think number 5 is?
Excuse me, teacher.
Yes.
I have to show you something.
Okay, go ahead.
Teacher, look.
Wow. That's amazing. Is that the solar system?
Yes.
That's very impressive. That looks like a work of art. Did you make that?
Yes.
Wow, that's very impressive. I feel like that should be up in a museum somewhere. That's a really wonderful looking solar system.
Thank you.
Yeah, thank you for sharing that. I even see asteroids in there, I think, which is very great and relevant to the talk. All right, I am going to move on to number 6. Remember, this is all just for fun, so it's okay if we don't know all of the answers. But let's go ahead and move.
Teacher, wait.
Yes, do you need an extra moment?
Wait.
Okay, I can wait a little bit.
Okay, teacher. Okay.
Okay, you're ready to move on. Great, let's take a look at number 6. Okay, make your guess of what this is showing a picture of.
Teacher,
Yes.
I need to be specific. That is shaped like a pickle.
Yeah, I would agree with you. I almost spoiled what this one is. I almost said the answer. I'll talk about it when we go over the answers. But yes, I agree with you. This is a very funny looking object. I almost said what it is because I wanted to talk about it so badly, but then I remembered we're playing a game, so I can't tell you yet.
Teacher, can we write the same answer 2 times?
Yes, thank you for asking that. I forgot to mention that. So since there are 10 questions and there are only 5 answers, you will repeat answers. This may be the same answer as one of the previous questions. You can absolutely write the same answer 2 times, maybe even 3 times. Would anyone like a little more time to make your guess on number 6? Okay, I will move on then to number 7, if we're all ready. Okay, let's take a look at number 7. Same answer choices.
I'm still writing.
Oh, you do still need some time. Okay, great. Let's go back to number 6 then. And again, for those of you who are ready to move on, think about how you would design a mission to move a rock in space?
Okay, teacher.
Okay, great. Let's look at number 7. And again, you will repeat answers. This might be an answer you have already written down. But for number 7, please write what you think this is a picture of. And please do not worry about getting any of these wrong. It's completely okay. But I'm sure many of you will get some of these right. It sounds like some of you might be experts on these. And I think if you know the difference between these objects, this picture might have a little bit of a hint in there, because if you look closely, you can see that there is somebody's arm in this picture and somebody's hand is actually touching this object. So that should tell you a little bit about what it is. The other objects that are listed here are not things that you could easily reach out and touch with your hand, but someone is reaching out and touching this object.
I know the answer.
Oh, great. Yeah, I'm glad that helped.
I don't know.
If you don't know, just make a guess. Or if you're not sure, if you really don't know what to guess, you can just leave an empty space and you can write in the answer when we show it. But I think the biggest hint is someone can touch this object. And if I think about touching some of the other objects, well, one of them would be very cold. In fact, most of them would be very cold, and it would be very hard to touch the other ones because they're in space. So you would need a spacesuit and a spacecraft to go out and touch most of them. But this one, someone is able to touch with their hand. So think about which of these answers you could reach out and touch with your own hand.
Excuse me, teacher. I had to ask you a question. Can a comet be bigger than an asteroid?
Absolutely. Yes. Yes. The answer to that is yes. Comets are sometimes much, much larger than asteroids. And in fact, there are new asteroids being discovered all the time as well. Yeah.
Excuse me, as you said, I knew the answer because you said that object is very small and someone is touching it. So from that I got the hint.
Okay, great. Yeah, we'll find out if you were correct on that one. Yes, because some of these objects would be very difficult to touch. But yes, to answer the previous question, comets are often much, much larger than asteroids. Okay. Would anyone like more time on number 7?
Can you go to number 8, please?
Yes, if everyone's ready, we will look at number 8. So we have 3 left, and then we can finally see if we got these correct. So number 8, and again, this may be an answer you have already written before. Please write what you think number 8 is. And if some of you do answer really quickly while some of your classmates are writing, I think it is great if you have other questions and you want to ask those to me now. Feel free to unmute and ask any other questions you have. Yes.
There are a lot of comets going in my living place.
There are a lot of comets going around there.
Yes. Sometimes there are comets and meteor showers.
If you're seeing comets going around in your place, that's very exciting. You should probably let astronomers know.
And I have seen a meteor shower.
Yeah, so if you've seen a meteor shower before, then what you have actually seen are pieces of comets. So you can say you've seen at least pieces of comets if you've seen a meteor shower. Most meteor showers are tiny pieces of comets that have broken off. Okay, would anyone like more time on number 8?
Can you go to number 9? What?
Yes, I'm ready to go to number 9 if you are.
Teacher, can you go to number 8?
We're on number 8 right now. Are you ready to move on to number 9?
I didn't write number 8.
Okay, let's
I
take a
can't
little
see
bit
the
more
board.
time.
I can't see the board even.
Oh, you're not able to see it? Should I go ahead and reshare it again just to make sure?
No, I can see now.
Oh, you can see it now. Great. Yeah, I will definitely have to send a calendar along of when the next meteor showers are, because certain meteor showers are easier to see on different locations in the Earth. I'm up more north than you are, so meteor showers that are very easy for me to see may be a little bit different than the meteor showers that are easiest for you to see. But it will be fun to learn about those, and they are really spectacular and really wonderful to see if you've never seen a meteor shower before. Or if you have seen one before, I think they're always exciting to see. Okay, are we...
Excuse me.
One more time?
Excuse me.
Yes.
Sometimes they post that there's going to be a meteor shower, so at the exact time I go outside, but sometimes I cannot see them.
Yeah, that can happen sometimes. So there are a few different factors that determine whether or not you can see a meteor shower. The weather, of course, is one. Sometimes if it's a cloudy sky, it's very hard to see them. And the other thing is that it's easy to predict when the meteor shower should happen. It's harder to predict what exact time the most meteors will appear in the sky. What I have found is that the best time to see a lot of meteors during a meteor shower is really late at night or very, very early in the morning, right before the sun rises is often the right time to see them. So sometimes getting up very, very early before the sun rises, maybe 2 hours or so before the sun comes up, that's often an easy time to see meteors during a meteor shower. Yeah, do you have another question or thought?
Yes, in 2015, no, I don't know the year, but they say that some kind of asteroid shape, some kind of asteroid, I don't know what it is, but it hit Russia.
That is really, really a coincidence that you mentioned that. I'm going to show a picture of that. That was in 2013. Yes, and that was an object that was about 20 meters across. So that's very large compared to something that we normally see on the ground, but it's still kind of small for an asteroid. And yeah, it exploded in the atmosphere over Russia. And I'm going to show a couple of pictures of that if we have time. Okay, I'm going to move on to number 9. So make sure you have your guesses for number 8. All right, great. The second to last question here. This is one that I've shown a different picture of earlier, so this may be a repeat answer for you. Please write down what you think number 9 is.
Done.
All done? Great.
Done.
Great. Wow, some of you were very quick on this one. You must know exactly what this is.
Easy.
All right, I'll give a little bit more time, or is everyone ready to move on?
Ready?
Easy peasy lemon squeeze.
What was that? One more time.
It was easy peasy lemon squeeze.
Wow, okay, that's very easy then. So if this one was so easy, let's go ahead and look at our final question, and then I'm very excited to tell you what all of the answers are. Here's number 10. Please write down what you think this one is a picture of, and I am very excited to tell you more about the object in this picture. But I won't tell you what it is just yet because you need to make your guess for what number 10 is.
Finished.
All right, that sounds like this one may have been a little bit easy too. But I think some of these are kind of tricky. This one might be a little bit difficult if you've never seen this before. And in fact, yes, go ahead.
Can I put a tip in your showing the answers?
One more time.
Can I put a tick when you telling the answers?
Oh, yes, I will tell you the answers in just a moment.
Excuse me, I have a question.
Yeah, what's your question?
In the image near, I'm not gonna say the answer, near the image, a little downwards, there is some kind of rock or something.
Oh, yeah, I see what you're referring to there. Yes. So on this image, that is still part of the same object. That's a reflection. So this is from when, and I almost said the answer too. I'll show you the answer very soon. This is from when the sun was hitting this object at a particular angle. So you're seeing a part of this object that sticks up. That is a rock that's sticking up and getting the reflection from the sun very clearly there.
Oh,
Okay.
I thought it was a small piece of rock just orbiting the thing.
Ooh, I could see why you would think that. Yes. So that might have changed what your answer is. That thing that you circled is actually part of the exact same object. This is all one object in this picture. I can definitely see how you would think that. All right. Does anyone want more time on number 10, or should we go on to the answers?
Go on to the answers.
Okay, great. What was that? Are you ready?
Yep.
Okay, great. Let's start with number 1. So what you can do is just use whatever system you want to make a mark on your paper for the ones that you get correct. And then at the end, we will take a look at how many you got correct versus incorrect. And remember, it's okay to get things wrong. It's all just a learning experience. Ooh, and if you drew that circle on the screen there, I can still see the circle on the screen. I don't know if you can, but if you would be able to, yeah, would you like to erase that circle if you made that red circle there? I'm not sure if I can erase that for you.
Wait.
I'm still able to see the red circle.
Ayush, I think there is an undo button on the screen. You could click on that. Did it work? No, right?
No, sir.
Okay, I think it's best if Miss Jenny can reshare it again. Sorry for that.
Okay. Oh, no worries. I don't have the power to erase it because I was not the person that drew it. So let's go ahead and quickly unshare, and then you can see the answer to this one, but we'll bring that back up and we can look at all of the answers again. Okay, great. So hopefully you can see that now. We don't have our circle there anymore. That was great that you pointed that out though, because I think that probably clarified the answer to that question. So number 1 was a comet. Feel free to mark on your paper if you got that right or wrong. Number 1 was a comet. And in fact, this picture number 1 is a comet called 109P, or sometimes this is called Comet Swift-Tuttle, which are the names of the 2 people that discovered it. This comet was discovered in 1862, and it takes 133 years to orbit the sun, which is a very long time to orbit the sun. Earth takes 1 year. This comet takes 133 times as long to orbit the sun. And I do see a hand up. Do you have a question?
Miss, the Hades comet. There's a comet called Hades comet. That comet orbits Earth every 75 years.
It was a little bit difficult to hear your question. I'm sorry. Could you say that one more time?
There's a comet called Hades comet. That comet orbits Earth every 75 years.
Oh, the comet that orbits every 75 years. You might be thinking about Comet Halley or Halley's Comet.
Yes.
Yeah, Halley's Comet is one that you all will probably have the chance to see return in your lifetimes. I might be able to see it. I will be pretty old when Halley's Comet comes back. I hope that I will be able to see it. I think all of you will definitely be able to see Halley's Comet when it comes back. Okay, so this was a comet. Let's move on to number 2. This was a meteorite. Remember, because meteorites go right to the ground. So mark whether you got this one correct. This is a meteorite that hit the ground in Arizona in the United States. So that's what this is a picture of. This one was a meteorite. So please mark if you got this one right or wrong. And another very cool resource that I can send along after this talk today for you to explore later, if you're interested at all in meteorites, NASA has a website where you can look at meteorites in 3D and spin around the 3D images and zoom in and see them from all of these different angles. And meteorites are interesting because they're pieces from the earliest years of our solar system that we are able to see. Yes?
From an app.
Did you say from an app? Or from an asteroid?
No, we have to we can do it in the mobile. We have to install the app, or we can get it for free.
Oh, you can, it's just a website, so you can get it for free. You don't have to install anything. It's a website that you can go to and you can click on different pictures of meteorites and they'll come up and you can just spin them around as long as you're on the internet.
Miss, I'm already using a NASA website.
What was that?
Miss, I'm already using a NASA website called Exoplanet.
Oh, you've been on a NASA website about exoplanets.
Yeah.
That's great. Exoplanets.
It's also 3D images.
Oh yeah, where you can go and visit the exoplanets in 3D.
Yeah.
Yeah, that's another really great resource. Exoplanets are a very, very popular area of astronomy right now, and I think will continue to be a very popular area of astronomy in the future. Okay, let's move on to number 3. See if you got this one correct. Number 3 is a picture of an asteroid. So you got this one right if you guessed asteroid. If you didn't get this one right, that's okay too. This one's a little bit hard to tell, but this is actually a specific asteroid. And yes.
First I thought it was a comet, and then I thought it was asteroid.
I got it right.
Wonderful.
I got it right.
That's great. So mark that on your paper somehow, because at the end, then I will ask how many you got correct versus how many were wrong. So asteroid Bennu is the name of this asteroid. And this is an asteroid we got pictures of because NASA sent a space mission called OSIRIS-REx that flew out to this asteroid Bennu. It grabbed a piece of it. And currently OSIRIS-REx is in space right now, flying back to Earth with a piece of this asteroid. So it's going to bring back a sample of that asteroid so scientists on Earth can study it and learn more about it. Yes.
Excuse me, when was when was it launched?
Ooh, OSIRIS-REx was launched. That's a really excellent question. It was launched somewhere in the 2010s. It met up with the asteroid just a few years ago, and it's going to be coming back to Earth, so returning to Earth's surface next year. So sometime next year is when we'll get that sample back.
So, as if how many years have passed since it launched?
You know, I don't know that off the top of my head. That's a really good question. I'll have to look that one up. I'm thinking it was probably somewhere around 2012 to 2014. I'll have to double check on that one though.
So, was OSIRIS-REx a personal mission easy to grab a sample of an asteroid, or it just met an asteroid and they just programmed it to grab a sample of it?
Yeah, that was part of the plan all along, was to grab a piece of this asteroid. And once it comes back to Earth with the piece of that asteroid, it will complete the first stage of its mission. And then what it will do is it will hopefully turn around, be launched again, and then actually plans to go out and study even more objects in space. So that will be its extended mission, to keep looking at other objects. All right, let's move on to number 4. So number 4, this is the one that was a drawing instead of a picture, and that's because this one is a meteoroid. Great. Yeah, so I know some of you were saying this one was easy once you saw that you had seen this picture before. This is a meteoroid. So mark whether you got this one right or wrong. And remember, a meteoroid is the smaller piece that breaks off of something larger, like an asteroid. So this one was a meteoroid, and I will move on so you can check your answers. Yes, go ahead.
Excuse me, I got the answer correct, but I missed one letter in meteoroid.
Oh yeah, these are kind of difficult words to spell, absolutely. Yeah, completely fine if you missed a letter in it. If you know what it is though, that's fantastic. All right, let's take a look at number 5. Number 5 is a picture of a meteor, because this, of course, is a streak of light up in the sky. This one was a meteor. Many people would see this and think it was a comet. If you thought it was a comet, that's completely okay. That's very, very easy to make that mistake. But this is a picture of a meteor, because it's a streak of light that goes by very quickly in the sky before disappearing.
Comets are some kind of fatter than meteors.
Yes, comets are much, much larger. A comet is also, because it's much larger, it's moving more slowly. So you would see it in the sky for a long period of time. Whereas a meteor appears and disappears very quickly. It just zips across the sky and burns up. Yes, do you have another question?
Yes, first when I looked at the question, I thought that it was a comet because it had a very long tail of light. But second, I thought that a comet's tail would be a little more longer, so I wrote the answer as meteor.
Wonderful. Yeah, so again, it's very easy to confuse a meteor for a comet. Okay, let's go through the rest of our answers. Number 6 is an asteroid. This is another asteroid.
The pickle.
Yes, it absolutely looks like a pickle. I often say asteroids look like potatoes. I think that very many asteroids kind of have these strange shapes. Yes.
It just looks like a chip in a pickle.
Some people say some people say like those.
Yeah, there were 2 of you speaking at the same time, so that was a little bit difficult to hear, I'm afraid.
Could you repeat it again?
Some people say that asteroids look like lumpy potatoes.
Yes, I think a lot of asteroids look like lumpy potatoes. I even think there are some moons that look like lumpy potatoes. So Mars has 2 moons, and a lot of people think that those might be asteroids that Mars captured as moons. And I think both of Mars's moons look like lumpy potatoes. So they are probably asteroids. Okay, let's move on to number 7. Number 7 is the one that someone's hand was touching, and this one was a meteorite because it came down to Earth. It came right down to Earth, so someone's hand is on it. Now, after we go over these answers, I know that we have about, if I'm looking at the time correctly, we have about 20 more minutes scheduled. So what I'll probably do after we go over these answers is I'll skip a little bit and then we'll just talk about the DART mission for the rest of the time, because that's what I'm really excited to talk about. And it sounds like many of you already know a lot about things hitting the Earth. So I probably don't have to tell you too much about that. Yes, sorry, go ahead.
Excuse me, teacher. Can comets come down to Earth and crash on the ground?
Yes, it's thought that that has maybe happened in Earth's past before, that comets can hit the Earth. But the good news is, because astronomers are tracking all of the nearby comets that we know about, there are no comets that look like they're anywhere close to hitting the Earth. The only worry is asteroids possibly hitting. Yes, go ahead.
Can you tell the 3 answers? 8, 9, 10.
Yeah, so if we're ready, let's go ahead and do the rest of the answers.
Excuse me.
Yes, go ahead.
First, when you told about the DART mission, you told that NASA built the spacecraft, crashed it into an asteroid to see if it moves. I thought it was crazy because it's such wasting a good kind of a good spaceship.
Yeah, I definitely understand how you feel that way. So the spacecraft had a lot of technology on it, and the spacecraft was destroyed when it crashed into the asteroid. But if we have to decide between destroying a spacecraft or protecting the Earth from getting hit by something, I think probably the best choice to make is to destroy the spacecraft so that we can protect all of the life on Earth. But it is a bit sad to see if spacecraft get destroyed. You're absolutely right. Okay, number 8 is a picture of a comet. And this is a comet called Comet Swan, and this one may actually not exist anymore. This is a comet that is thought to have gotten so close to the sun that it may have burned up from the heat of the sun. So this comet may not even be there anymore, and that can happen to comets.
I mean, it's very beautiful.
I do think it's very beautiful. Comets are very beautiful, and it's very interesting too, because comets become this beautiful when they start breaking apart. That's when we're able to see them looking this beautiful in the sky. All right, let's take a look at number 9. Number 9 was another meteor. So mark whether you got this one correct. This one looks a little bit like a comet, so it is okay if you guessed comet.
Excuse me?
Yes.
I got all correct till up to 9.
Can you say that one more time?
I got all correct till up to 9.
Wow, that's amazing. Yeah, so at the end, I'll ask if anyone wants to share your final scores.
Miss, me
Yeah.
also the same. Me also the same.
Did you say meteors are the same?
Oh, Miss, I said I also my all are correct until 9.
Oh, wow. Okay, so some of you are very much experts. That's great. That means that after I show the final answer, we can skip right into talking about the DART mission for the rest of our time. So that brings me to number 10. If you got number 10 correct, you wrote asteroid, and this is an asteroid.
I got all correct.
Wow, that's amazing. So number 10, this asteroid, it's same as Dimorphos. Dimorphos is the asteroid that DART spacecraft crashed into. So this picture that you are looking at is one of the last pictures that the DART spacecraft sent back to Earth before it crashed into the asteroid. So DART was taking pictures as it was getting closer and closer. And I'll show you a video as well of some of those final pictures before it crashed. Yes.
Excuse me.
Yes.
As if the spacecraft crashed into the asteroid, did the asteroid move or was it destroyed into pieces?
Ooh, we will get to that. That's where I will end today. What do you think happened? What would you guess happened? Do you think that it moved it, or do you think it broke into pieces?
I think the asteroid moved because the spacecraft isn't that much stronger to break a meteor apart.
I think that's a very good guess. Yes. And remember, the goal would be to move the asteroid. We don't want to explode the asteroid unless we have to, but moving it is a good way to keep it from hitting our planet. Okay, that was...
But if it was blown up, some of the pieces of the asteroid would come and attack the Earth.
Exactly. And that would be very bad, to make a big rock become a lot of small rocks. That would be a bad result. So we don't want that to happen. I do see a hand raised. Yes, go ahead.
Teacher, I got 8 wrong and 2 right.
If you got any of them right, I think it's very impressive, because some of these were very, very difficult. Would anyone else like to share your answer? If you like, you can hold up the number of fingers of the answer you got, or you could type it in the chat. How many answers did you get correct out of 10? Or if you don't want to share, you don't have to.
I got 3 wrong, 7 correct.
Wow, that's wonderful. And if this was a very difficult quiz, I will tell you that it is a very difficult quiz for most people, including even some scientists. Sometimes scientists forget the difference between meteor, meteorite, and meteoroid because they're so
Excuse
similar.
me.
5 correct. Very good. I see a hand there. Yes, go ahead.
Excuse me, I got all correct.
Wow. So we are going to say you are a space rock expert if you got them all correct.
Miss, I got my all are correct. Miss.
Wow.
Miss, my all are correct.
Teacher,
Amazing. Go ahead.
excuse
Yes.
me, madam.
Oh, there are lots of you talking at one time.
Excuse
It's-
me, madam.
It sounds like many of you got a lot of them correct. Yes. Does someone have a question?
Madam.
Yes, Anu.
Yeah.
Great, and I got
Oh, it's a little hard to hear you, but it looks like you got
I got 4 wrong and 6 correct.
6 correct is great. That's wonderful. Okay, it sounds like lots of you are experts on space rocks, which is great because what that means is I will skip talking about what happens when the rocks hit Earth because some of you know that a very large rock hit and
Excuse
caused the
me,
extinction of the dinosaurs. So it sounds like you know a lot about that already. Yes. Do you have a question?
Excuse me, teacher. I got 5 wrong. I got 5 correct.
Wonderful. Half correct is very, very good. These were difficult questions. Okay, let's quickly then actually talk about the DART mission because that is all about asteroids. So it sounds like many of you know a lot about space rocks already. Let's talk about moving a space rock.
Excuse me, madam.
Yes.
May I drink some water?
Oh, yes, of course. Yeah, go ahead. That's always a good idea. Okay, so let's take a look at this picture here together to make sure that before I leave this evening, you all have a good idea about what the DART mission was. And then what I can do is I will leave with your teacher some other activities because we may not have time to do the activity where you're designing a space mission, but it sounds like some of you are very interested in designing things like spacecraft. So what I will do is I will leave that activity. And if you would like to design a spacecraft and a space mission after this talk, then maybe that is something that your teacher would be able to share with me. And I'll make sure you can pass that along. Does that sound okay? All right.
Okay.
Wonderful.
Sorry for interrupting, Miss Jenny. Like, if you don't mind, like, if you have time, is it okay? Like, if you could do another extra 30 minutes, that'd be fine.
Yeah. Does that work for everyone? I don't want it to get too late there.
We could. Yeah, we could.
Okay, great. So if that's the case, then
Thank you very much.
yes, absolutely. If that's the case, then I will go back and I will show a couple of pictures of some craters on Earth then, just to make sure, because one of you mentioned one of these, and I thought that was a really great coincidence. So maybe I will show a couple more pictures of those. Okay, fantastic. So let's talk about things that do hit the Earth's surface, and I'll show a few pictures of what that looks like. So we call these impact craters. Impact craters are what we call it when an object like a meteorite crashes into the surface of a larger object like a planet, such as Earth, or like the moon. This is a picture of an impact crater on Earth. This is in Arizona in the United States, and this crater was formed about 50,000 years ago when something crashed into the Earth's surface. So the object that caused this crater was about 45 meters wide, and it was traveling at over 45,000 kilometers per hour. So when these things come in, they hit very, very fast. Yes.
Excuse me, you said there was an image of the crater of an asteroid that extincted dinosaurs. Is it bigger than the crater?
Oh, it's a much bigger crater, the one that caused the extinction of the dinosaurs. So I'll show you a picture of that one. That one's a little bit different though, because it's very old. And so sometimes when craters are very old, they actually get covered up by the natural processes on Earth's surface, like weather. So I will show you a picture of the one that caused the extinction of the dinosaurs a little bit later. I will show you a couple more craters though. And this one's a little bit different. This is a crater that is not on Earth. Would anyone like to guess where this is
It is in the moon.
located?
It is in the moon.
Yes.
In the moon.
In the moon. In the moon.
Mm-hmm.
I
Yes,
could recognize
absolutely.
it by the lunar surface.
The moon
Yeah.
surface has small craters. So in the middle you can see a big crater and it's ash colored. So we can recognize its moon.
Yeah, so all of you seem to look at this and immediately say that's the moon. And maybe you even recognize the specific crater that it is on the moon. It's this crater that you sometimes see on the bottom there. It usually looks very bright white. This is a very famous moon crater. It's called Tycho crater, and it's one of the easiest to see craters on the moon. You can usually see it on the bottom on the southern hemisphere of the moon, and it usually looks very bright. This crater. Yes? So this crater is 100 million years old. That probably sounds very old, but for a crater on the moon, that's actually pretty young. Craters on the moon sometimes go back way back in time beyond this one. And this is a very interesting picture of the moon's surface. So this yellow is a drawing over top of this picture. And the yellow path is actually showing the footprints from astronauts walking on the moon in 1971. But this picture was taken 40 years later. So the moon is a very interesting place for craters, because when things leave an impact on the moon, even something as small as footprints, nothing happens to them. Those craters don't go anywhere. Even footprints from people walking on the moon are still there today. And that's because the moon doesn't have all of the same processes that the Earth has. Here's an example of how craters can change over time. So this is actually a picture of the world's largest impact crater. We're back to Earth now, and it's kind of difficult to see this crater, even though it's one of it's the largest one, and it's actually one of the oldest craters on Earth too. The reason this is so hard to see is it has to do with the weather and the processes happening on Earth's surface. Because it has been 2 billion years, the weather has changed this crater over time. Yes.
Excuse me, I cannot see the crater. Is it the half circle or is it the whole thing that's great?
Yeah, so wonderful question. It's very hard to see, right? It's the half circle there. So the point of me showing this picture is that it is very difficult to see, even though it's such a large crater. And that's because it used to be a full circle that was easy to see, like the craters on the moon. But over 2 billion years, things like plants and water and wind and volcanoes and other geologic activity have changed the appearance of this crater so much that you can really barely even see it anymore. So that one has changed a lot over time. Now, speaking of... Yes, go ahead.
In my book.
Can you say that one more time?
Excuse me, in my book, it said that every 1,000 years an asteroid impacts Earth's surface.
Yeah, so as I said, there are objects hitting the Earth all the time. The ones that hit at certain times, it depends on how big they are. So I will show you a picture showing the different sizes of asteroids. But yes, the Earth is still getting hit with objects. It's just that most of them are very, very small. Okay, let's take a look at something that one of you...
Crack or something behind the crater?
What does it look like is behind the crater?
A crack?
Yeah, it does look like that. That's because the Earth has changed so much since that time. That's probably a fissure in the Earth's surface, or maybe a remnant of something like a stream or flowing water at that time, which would be one of the processes that wears down the appearance of that crater.
Excuse
So-
me.
Yes.
Is the crater in a wall or a ground surface?
Oh, good question. Yeah, that is a picture from above, the one that we just looked at, looking down at the crater. So looking down from above. So that would be flat on the Earth's surface on the ground. Now, sometimes the objects don't make it all the way to the ground. One of you mentioned this one that happened in recent history. Yeah, so you actually mentioned one that I had pictures of. This is that meteor that was seen over Chelyabinsk, Russia, and that was in 2013. So this is something that was about 20 meters across, and it was early in the morning. It exploded over the atmosphere of Russia, and it did damage some buildings. Some people did unfortunately get hurt because it was such a powerful explosion. And
Excuse
one
me?
thing that, yes, go ahead.
As the information, 1 or 2 people died because of the explosion and they were inside the building.
That's true. Yes. And because the reason for that is because it was such a powerful explosion that the windows were exploding. So there was glass flying everywhere. So it's a little bit scary, but it would have been a lot worse if it hit the ground. This actually exploded in the air above. Now, one of the things that's weird about this explosion is that nobody saw it coming ahead of time. We have all of these powerful telescopes, but nobody could see that this object was coming. And that's because it was actually coming towards Earth from the same direction as the sun. So this bright flash in the picture, it looks like the sun. That's actually the object itself. So that's one big difficulty in finding these kinds of objects before they enter the atmosphere, is that if they're coming from the same direction as the sun, it's very hard to see because, as I'm sure you know, you don't look right at the sun. You definitely do not point your delicate telescopes right at the sun. So sometimes that makes these objects difficult to find. I see a hand raised. Do you have a question?
Teacher, do asteroids come to Sri Lanka and in every country?
Yeah, so everywhere on Earth has the possibility of objects from space actually going to that area. Like I said, though, the large objects you don't have to be too worried about. Most of these objects are things that people have found. But yes, it's hard to predict exactly where on Earth things will come to. One thing that I am curious if you all have had any famous meteorites there. So that is something that I will look up if that happens. Yes, is there another hand raised?
Sorry for interrupting, students. If you don't mind, is it okay if we ask questions at the end, because we can give some time for Miss Jenny to finish the lectures because she has taken extra time. So that would be great. Yes, Miss Jenny.
Great. Okay, yes, I think that's probably a good idea just because I do want to make sure you hear a little bit about NASA's DART mission before I leave, but I will leave some time at the end because actually some of the questions you're asking might be things that I'm planning to answer. So we'll wait until the end and see if you have some other questions at the end there. Okay, let's look at some other examples of things that have hit the Earth and why we care about trying to stop things from hitting the Earth. So these are some older pictures that you can see here. These are pictures that show what happened when a larger object about 50 meters across or bigger entered Earth's atmosphere over a forest in the Tunguska area that's also near Russia. This happened in 1908, and it was very lucky that there were not very many people around, but it did knock over an entire forest. It's hard to see in these pictures, but these are trees that got knocked over from this explosion, and these pictures were taken about 20 years after this happened. So bigger objects coming into the atmosphere do mean bigger impacts on the surface. And I know you all seem to know about the one that caused the extinction of the dinosaurs. This is another one that happened so long ago that it's very difficult to see the crater now. This was a much, much larger object that was closer to 10,000 meters or 10 kilometers in size. And this affected all of the life on the planet, as you know, with what happened to the dinosaurs. So even though it hit this one area, in the peninsula on Mexico, it actually affected all of the life on the entire planet because it was such a big impact. Now, I know it's hard to see the crater, and that's why we have to use different special types of scientific imaging. So you can see the real picture on the left is harder to see. You almost can't even see the crater there. And that's because so much of the swirling materials in the ocean near this peninsula came in and filled in the crater, because this happened about 66 million years ago. But it is definitely the case that much larger objects have hit Earth's surface and affected the entire planet in the past. Okay, let's take a look at different categories of asteroids. One of you mentioned that you had read that about every 1,000 years or so, an asteroid might hit the Earth's surface. So actually, there are different sizes of asteroids that hit Earth at different frequencies in time. And I think the ones that we're most worried about as astronomers in terms of what might hit the Earth, this category might surprise you. So if you start with the section that I called E on the very end, those very, very big objects, these are like the ones that killed the dinosaurs. The good news is astronomers know where 100% of those objects are located. So we are not worried about a dinosaur extinction size rock hitting the Earth, because those have been discovered so far. And then if you go down to the size category that I labeled with D, those are the sort of things that happen every 500,000 years or so. And those have pretty much all been found and discovered already as well. The objects in categories A and B are a little bit smaller, so we're not too worried about those always damaging the Earth's surface. But you can see that I circled the category called C in the middle, and those are objects that are about 160 meters across. It's thought that these hit the Earth maybe once every 25,000 years, which doesn't sound that often, but one thing to know about these is that we've only discovered about 40% of the objects in this size category. Now that's a little bit weird, right? Because how do we know how many are out there if we haven't discovered them all yet? And the reason for that is that people do computer simulations for how many of these objects there should be based on what we know about the solar system. And we think that we have only found about half of them. So one thing that's important to know, since we're about to talk about the DART mission for stopping an asteroid, if there was one headed toward Earth, is that the first thing we need to do is discover them. So if you are thinking about becoming an astronomer, one area of astronomy that you can become involved in is the detection of near-Earth asteroids. This is a very active area of science, and this is one that many people will need to contribute to in the future, because if we have located all of these asteroids, then we can launch missions like DART that try to stop those asteroids from hitting the planet. So this is where this phrase called planetary defense comes in. And that's something that I will be talking about with regards to the DART mission, worldwide planetary defense. And this is something that does take people from all over the planet, because we all live on the same planet together, and our planet needs to be protected from objects from space hitting it. Planetary defense is what we call it when scientists are working together to reduce the chance that something will hit Earth. First, you have to search for and locate those objects using telescopes on Earth as well as telescopes in space. Then you try to learn more about the characteristics. You find out, what are these objects made of? What is their composition? How are they moving in space? Where will they go in the future? And there's a lot of planning involved. The category that I circled is called mitigation. And this is the one that includes NASA's DART mission, which is the last thing that we will talk about today. But I did promise you that there would be one other activity and chance for you to participate. So let's go ahead and do this one other activity, or at least get started on it. I'm not going to give too much extra time for it, but I want to talk about being planetary defenders, where you can come up with your own idea about how to defend Earth. And then if we don't have time to finish that, then maybe what I will do is I will ask your teacher if there's anything completed afterwards, and maybe you can send that along so I can view some of the responses. So like I said, the DART mission tested one way that we could stop a dangerous asteroid from hitting Earth. But there are many different ideas that people have. So if you would like to start to participate in this activity, then go ahead and have your notebooks and something to write with ready, and you're going to come up with an idea. Now, this will be a little bit different because you may just have time to get started on that idea. But let me show you some pictures to give you a few ideas for what you could come up with for a space mission. So maybe you already have your own idea, but here are some pictures showing different ways that people on Earth have suggested for how you could stop an asteroid if there was an asteroid heading towards Earth. So you can see starting in the upper left. Yes?
Excuse me, when we were doing the questions activity and the rocks activity, after I finished, I wrote half about it, and now I'm finished.
Oh, really? Okay. Well, I'm only going to give a few minutes for it. So maybe you can add a little bit more to that idea when we're doing some time for that, just to make sure that other people have a chance to do that too. I'm only going to give about 5 minutes to come up with ideas. So that's great that you have something already. What was that?
We had to write.
You don't have to. You could draw a picture as well. So that's why I'm showing some pictures here.
Excuse me?
Mhm.
Could I tell my one?
Can I go through these ideas first? And then at the end of that, I'll ask if anyone wants to share theirs, okay? So just
Okay.
hold on a moment. Okay, great. I want to make sure that other people have a chance to come up with their ideas before they hear yours, just in case other people have different unique ideas. So here are some things to maybe inspire you if you're wondering.
Madam,
Yes?
what do
Uh-huh.
we need to draw?
So I'll show you some pictures that you might think about drawing. These are some ideas people have had about trying to protect Earth from asteroids. Some ideas are shooting the asteroid with lasers that break off pieces of it. That's a real idea that scientists have had. We've never tried that one. Another idea is using gravity and big spacecrafts that can pull an asteroid and move it to a different location through the force of gravity. The DART mission used the example called kinetic impactor on the bottom left. That's where you crash something into an asteroid to try to move it. And there may be some other ideas that you have too. So I do want to wrap up today by talking about the DART mission, but I know that some of you might have some interesting ideas. And I think if we're going to end in about 22 minutes based on my clock, let's take just 5 minutes of that time for you to come up with some
Teacher?
ideas. Go ahead.
Can you show me some more telescopes?
Some more what?
Telescopes, pictures?
Oh, telescope pictures? I can send some telescope pictures. I have one more later. I do have a telescope picture, actually 2 more telescope pictures that we might have time to get to. So we'll take a look at those a little bit later. For now, I'm going to give you 5 minutes to come up with an idea. Just because I think it's really good to imagine before we find out what did the scientists actually do. And then you can find out if your idea is similar or different from what scientists did to actually move an asteroid. Yes, go ahead.
Excuse me, I have finished. In my idea, it's a little closer to the gravity and to move it with gravity, but not a little. It's a little different than that.
Okay, great. So what I think we'll do is I'll give you a few minutes if you want to add to that idea, and so other people can get started on theirs. And like I said, you may not have time to finish, but here's what I'll ask you to do if you haven't started yet, is to just imagine that there's an asteroid on a path to hit Earth. And don't worry, this is not true. You were just imagining. There is not an asteroid that's about to hit Earth. But imagine that there was, and your job is to design the plan to stop it from hitting the Earth's surface. If you want to draw a picture, you can draw a picture. If you want to write something, you can write something. And remember, there are some ideas on here already. You could hit the asteroid. You could use gravity to move the asteroid. If you like, you can try to make the asteroid explode. We talked about that as another possibility as well. Or you can be creative and come up with your own idea. But what I will do is I'll just put a few minutes on this timer for you to have some time to imagine. And then we'll move on and talk about what NASA actually did. Okay, let's just take a few minutes of time for you to imagine your own ideas. And then I'll ask that you pause so that we can continue and talk about NASA's DART mission. Actually, let's just do, since we talked for a little bit, let's just take 3 minutes of idea time here. This may not be enough time, but just so you can get started on your ideas, let's take 2 more minutes for you to get started on your ideas. And then what I think I'll do is I'll talk about the DART mission, and then with that time at the end, when there's a little bit extra time for you to ask questions, if anyone would like to share them at the very end of the talk, I think we'll take a moment then and I'll ask if anyone has some ideas to share, because it sounds like you probably have some good ones. And I know that a few minutes is not nearly enough time to plan a mission to defend Earth, but I think it's really good to take some time to get started on that idea. So let's just take about 1 more minute to get started. I know we don't want to take too long with that, but you can always finish this afterwards. And I would be very excited to have some of these sent along if you maybe can take pictures of them later. I'm going to move on in about 30 seconds. So I will ask you to pause your ideas. I know it's hard. I wish we had more time to do this, but I will ask you to pause your ideas in now about 20 seconds and just put those down so you can hear about what NASA really did. And maybe if you're having trouble coming up with some ideas, maybe when you find out about what NASA actually did this year, it will help inspire you to add some things to your own ideas. Okay. Let's go ahead and pause your drawings where they are, or pause your writings where they are. And you can always pick those up again later. And I see some really great starts to plans there. So here's what I will do. I am going to talk a little bit about DART now. And when I'm done talking about the DART mission, there will be a few moments. I will make sure to pause just a few minutes early. And then if you have some things that you would like to share at that point, you can go ahead and share those. But I do want to talk about the DART mission. So if you take a look at this picture, maybe you can also get an idea of some of the features of spacecrafts. If you're somebody that drew a spacecraft for your idea, you might see some things in these pictures and think, oh, I need to add some things to my spacecraft, like make sure it has different technologies and solar panels. So here is what NASA actually did a few months ago to move an asteroid in space. These are the 3 main goals of the DART mission. The first one was to find this binary asteroid system. Binary means that there were 2 asteroids in this system. There still are 2 asteroids in this system. To find this asteroid system, to impact the smaller asteroid. So there's a smaller asteroid that goes around a bigger one. The spacecraft wanted to crash into the smaller one and see if it could move that small asteroid in its orbit around the larger asteroid, because if we prove that crashing a spacecraft into an asteroid can move it, that means that that is a good technology to use if there was an asteroid on a collision course with Earth. So here's an animation of what this might look like. You see this little asteroid named Dimorphos goes around the bigger asteroid. The DART spacecraft comes in, it has an extra satellite with it. DART crashes into the smaller asteroid and then hopefully moves it into a new orbit. So a lot of people worried, well, what happens if the spacecraft knocks this asteroid on a collision course with Earth? But as you can see, the spacecraft is not very large compared to the asteroid. It's drawn a lot larger in this picture here. So what it was doing was moving the asteroid, the little ones, closer to the bigger one. And by moving it closer, that means that we can prove this technology works to defend Earth. So here are some actual photos of these. You've seen a picture of this asteroid before. It was number 10 in the quiz that we did earlier for What's That Spacerock. So there are 2 asteroids in this system. That's why DART stands for Double Asteroid Redirect Test, because it's a double asteroid system. What DART wanted to do was hit the smaller one called Dimorphos, which orbits around the larger one called Didymos. And these are fancy Greek names for these. The larger one, Didymos, means twin in Greek because we knew that it had 2. It's a twin asteroid. Now, the hope was to change the orbit of the smaller asteroid by just 1%. I know that sounds very small, but if you can prove that you can move it by 1%, and you do that long enough in advance, then that small change would add up to a much larger change over time. So that means that if there was an object that was headed towards Earth, you could hit it into a different path so that before it gets to Earth, instead of hitting Earth, it would just barely miss Earth. But I think it's very important to mention that this was only a test. These asteroids are not actually any threat to Earth. Okay, if you're drawing a picture of a spacecraft, make sure you take a look at this spacecraft on this picture here and see if you want to add anything to your own, because this is what the DART spacecraft looked like before it impacted the asteroid. The main science instrument of this spacecraft is called the Draco camera, and there's a picture of that on the bottom. Draco took pictures on this journey to the asteroid, and it sent those pictures back to Earth as it prepared to crash into Dimorphos. There were a lot of different technologies included on this spacecraft, and we will look at just a few pictures of those in detail. I like to show pictures like this because it shows that there were so many people. Yes, go ahead.
Teacher, can you show the animation, teacher?
Oh yeah, I can show you that one more time. Yeah, that's a really helpful image to find out what happened here. So this animation here, if you want to watch this one more time, and I know some of you are adding to your planetary defense plans, but make sure you see this animation too, because this may give you.
What does that LICIA cube?
Yeah, that's called Lichia Cube, and that's an extra satellite that rode along with the spacecraft because DART is exploding when it hits the asteroid. It can't take pictures after the impact. That is an extra, you see it coming out right there, that's an extra satellite that rode along so that when DART crashed into the asteroid, that Lichia Cube satellite could take pictures afterwards. And we'll actually see a few pictures that came from that. Yes, go ahead.
When the dark sunlight push the asteroid into another direction, do we have pictures of the new orbit?
So we have data and we have information of the new orbit. We don't have very good pictures showing it just because this is so far away, but I will show you the pictures that we do have. So one of the behind the scenes photos I can show you, one of you mentioned that Lichia Cube. This is something that was contributed to the mission from the Italian Space Agency. And this is a small cube satellite. It's not very big, but it was good enough to take pictures after the impact happened. So that's this extra piece that rode along with the spacecraft. So when DART launched, and it launched a little over a year ago in late 2021. It launched with the DART spacecraft and with that extra satellite, that Lucia cube with it. And then it started flying through space. So what I'm about to show you now are some pictures that the spacecraft took as it was on its way, and at least one picture from little Lucia cube, that tiny satellite. So here's us following along with DART's journey as it made its way to the asteroid that it eventually crashed into. This picture may not look like much, but it's important because it shows how far away this system is. So this spacecraft launched in November of 2021. Then many months later, in July of 2022, earlier this year, it was still this far away, but the spacecraft finally found what it wanted to crash into. This is a picture taken from that little Lucia cube satellite. So it turned around and it took a picture of Earth. And I always think this is a very fun thing that space missions do when they're headed out into space, is sometimes they spin back around and they take a picture of home. So this is actually a black and white photo of Earth as seen from this satellite.
That looks
Okay.
like the moon if you turn it upside down.
It absolutely does look like a picture of the moon. And that's, of course, from different locations in space. You would see phases of Earth, just like you see phases of the moon. All right, now we are at September 26th. So this was just a few months ago. We will start looking at the pictures that the spacecraft was sending back. So here's one picture from an hour before DART crashed into the asteroid. And this was a very big day for the mission. So this is the picture. And believe it or not, there are 2 asteroids in this picture. To my eye, I only see one. Maybe if you have better eyesight than me, you can see 2 asteroids in this picture. Luckily, the spacecraft has better eyesight than I do. So now let's zoom in so hopefully everyone can see the 2 asteroids. So this is a picture.
Yes, I
Yes.
can see that.
I can see too.
I can see.
I can see too.
Yeah, and this one I can finally see 2 as well. I could only see 1 in the previous picture. And from Earth, we can only see 1 as well because the other one is so much smaller. But now you can hopefully see both of them. So the DART spacecraft sent this photo back about 30 minutes before impacting. And you can now see there are 2 in this photo. Remember, the goal is to hit the small one, not the big one. This is a picture from 20 minutes before impact as DART gets closer and closer. And you can start to see kind of the...
21 minutes.
Excuse me, teacher.
21 minutes.
Yeah, 21 minutes, yes.
Excuse me, teacher.
Yes?
Shall I show you something?
Can we wait until the end so I can make sure that I can get through DART? Would you mind waiting until the very end?
Okay.
Okay, I want to make sure that you see what happened when it crashed into the asteroid, but then I will make sure to wrap up a little bit early because we're almost at crashing into the asteroid, and that's the really exciting part. So we get closer and closer. These are pictures being sent back from the DART spacecraft. So we're about 10 minutes, a little less than 5 minutes, getting closer and closer. And at this point, the spacecraft is actually crashing itself into the asteroid. People on Earth can no longer communicate with it. So the spacecraft has been programmed to be smart enough to crash itself into the asteroid. So it gets closer. Now we're about 1 minute away. You can see that the bigger asteroid is almost not even in the picture anymore. That's it to the bottom left, just about to go out of the view. So we're getting closer to Dimorphos, the small asteroid target. And then I will show you these final pictures. I will tell you that at the very end, the last picture only got sent back a little bit of it because the spacecraft exploded. So it's going to flash bright red at the end of these pictures, and I'll tell you why that is. But here's the last images coming back as DART gets closer and closer. You can see that lumpy potato shape of the large asteroid. But remember, we want to hang out and crash into the smaller one. So it's getting closer and closer. The spacecraft is smart enough to find this asteroid.
Eating a sperm or something.
Yeah, it does have a weird look about it. Okay, now we're getting closer. The pictures are slowing down. And This last picture looks like this, and that's because this was confirmed to impact. So it's bright red because when DART hit the asteroid, it only had time to send the top part of that picture, and then the signal disappeared because the spacecraft exploded. So that's why this turns into only a partial picture at the end there. So this, yeah, let's watch that one more time. I think this is probably the coolest part. So we'll watch this one more time, and then I'll show you the last final picture. And then we'll talk about whether or not it actually moved the asteroid. What do you all think? Do you think it successfully moved the asteroid? Yes or no?
I think it successfully moved.
Yeah? So here we are one more time, and the goal was to just make a head-on direct crash to the asteroid, and it does make the crash. So then we'll talk about what happened. So getting closer and closer, and then that last image, it only sent back a little bit of it. So here's the second to last image, the one that we actually saw the whole image. No one had ever seen the surface of this asteroid ever before. This was the first time we ever looked at it. So let's look at some pictures of what this crash looked like from other perspectives in space. Remember that little cube satellite, Lichia Cube? It took this picture after the impact. So on the bottom, that's the big asteroid. On the top, with all of that dust and debris coming off of it, that's the asteroid that got crashed into. So you can see that when DART crashed into it, it sent up all of this dust and material off of that asteroid. This is another animation for you. It's a little bit slower, but you can see this from a different view. So this spacecraft.
Picture you show.
Sorry, Thyssen, is it okay if we can let Ms.
before,
Jennie finish
and
this
the picture we can
lecture? And then we can go on to the questions, because I think she has quite a few slides to cover. So once all the slides are covered, then we may ask the questions. All right. Okay.
And
Yes,
we
Ms.
are.
Jennie.
We're almost at the end too, but
Okay.
I just want to talk about exactly how much it was able to move it. So here's a different view of it. Let's look at a few more views, and I heard at least one person predict that it did move the asteroid. We'll talk about, yes, it did, and how much did it move the asteroid. So here are some other pictures that Hubble Space Telescope took, showing how that dust or that ejecta looked after the impact happened. So this is 22 minutes, 5 hours, and 8.2 hours after the impact happened. This is what the system looked like, and that's all that dust because the spacecraft hit it so hard that it sent all this dust flying. This is a picture from the new Webb telescope, JWST. It took this picture as well. And again, lots of dust flying off of the system, which shows just how much of an impact the spacecraft made. The next thing I'll show you very quickly is a map of all of the different locations of some telescopes on Earth. Now, these are the ones that are officially being used to help NASA see what happened to the asteroid, but it is important to mention that there are other people with telescopes not listed here everywhere around the world who were observing this system. And in fact, if you had a powerful enough telescope, you could see this right now from pretty much anywhere on Earth. There's some places in the very south of the Earth that it would be hard to see, but many people all over the world turn their telescopes to see what happened, and here's the result. It did work. If you predicted it worked, it did absolutely move the asteroid. So as the smaller asteroid orbits the larger one, what we can see using our telescopes on Earth is that sometimes the brightness of the asteroid changes. And that's because sometimes the small one goes in front of the big one, sometimes it's off to the side of it, and sometimes it goes behind it. So we knew from observing this system that the small one, okay, I don't think that's a question. So we know that the small one took 11 hours and 55 minutes before DART hit it. It took 11 hours and 55 minutes to go around the big one. Afterwards, it took 11 hours and 23 minutes. So if you do the math on this, it means that DART changed the amount of time that it took for this asteroid to do its orbit by 32 minutes, which is a very big change. What this proves is that you could absolutely use this to protect Earth. If there was something headed towards Earth, you can definitely crash something into a rock like this in order to move its orbit. Now, this is a very technical slide, but it's an important slide because it just proves to you how scientists know the orbit was successfully changed. These graphs show how much light you can see coming from that asteroid system. So as you look, there's a straight line of the light coming from the system, and then sometimes there's a dip in the light. And so what were astronomers looking for? They were looking for that dip in the light to be at a different point in time. And what all of these telescopes on Earth all found and verified was that that dip in the light shows that DART did change the orbit of this asteroid by 32 minutes, which is a very big change. So we know that this is a successful technology. The next thing to happen is that the European Space Agency is going to send another spacecraft called the Hera mission. It will get to the asteroid system in 2026, and it will take a final look at that system to see what does it look like after that, and how can we maybe use this technology in the future. I promised one more picture of a space telescope, so this is another one to pay attention to in the future. This telescope will be called the Near Earth Object Surveyor, and what it will do, and it's set to launch in 2028, what it will do is it will look for all of those hard to find asteroids, because if we can find the asteroids, then we can protect Earth from them. And among the other things that I will send along for your teacher to give you is this quiz. It's another little game that you can take online. And if you go to this website, it's completely free. You go to this website and you can get a virtual badge that says, I am a planetary defender. So this is a picture of my virtual badge that I got from taking the quiz. And I'm sure that some of you will also be able to take this quiz. It's also about 10 questions, and you can be a planetary defender as well. And that's the end of my slides. So yes, question. Uh-huh.
Are we gonna get that badge? If we get some wrong, are we still gonna get that badge?
So the good news is that you can take it over and over again. So if you get some wrong the first time, you can take it again and it's the same question. So if you remember the correct answers, you can do it one more time, and you can also be a planetary defender. And I'm sure that all of you, if you want to get this, are capable of getting that planetary defender badge. All right. Yes.
Could I tell my idea about the we need to write our own mission like that one?
Yes, absolutely. I think now would be the perfect time. So let's, just to make sure anyone who has the desire to share out has the chance to share out. Let's do just one contribution per person. So let me actually take my slides down so that I can see if I have anything to show. And anyone that wants to show something will be welcome to show something.
Teacher,
Yes.
Excuse me.
I made a laser telescope.
Demet, if you don't mind, can we give the chance to Ayusha, because he raised the hand first. So after Ayusha, we can go with Demet.
Okay.
All right. Yes, Ayusha, go ahead.
My idea was to build a spacecraft, send it near the asteroid. Somehow we could attach this. This would be a far-fetched idea, but somehow we could attach it somehow to the spacecraft. Even though it would take lots of years, we could move it out of orbit very far away from Earth.
Wow, so it does sound like you came up with an idea that's very similar to the gravity idea from moving it using a spacecraft.
Yes.
That's wonderful. Yeah, I love that idea because no one has tried anything like that yet. So I think that's a really fantastic idea. And now that we know something like crashing into an asteroid works, now would be the perfect time to start trying something like what you suggested and seeing what other ways can we possibly move an asteroid. So thank you so much for sharing that. I know there was someone else who wanted to share an idea as well. Do you want to go ahead and share yours?
Teacher.
And in fact, maybe we'll let your astronomy coach decide who goes next, because I think there are many of you that might want to share.
Yep, that's right. So first, let's go with Demet and then Sadaha.
I made a laser telescope.
Wow, a laser telescope. So what is it going to do with the lasers?
There's a laser pointer and a solar panel and there's a two antennas to connect with Earth. And when you on the button in Earth, it hits the laser hits the asteroid and breaks it into parts. And there's a little camera that can show how it works, it exploded. And I made another little telescope that's partner and that's name is MSDW, which can also has a camera. It sets to two pieces, and the laser telescope name is JSBW.
That's wonderful. It's very smart of you to send something along that can take pictures after the lasers work on the asteroid too. So I think you really covered a lot of different things with that idea. That's great.
And I put a name.
Yeah, it's important to pick a good name as well, definitely.
I put JWSBW, and for the small partner I gave a name MSBW.
Wonderful. Would anyone else like to share their ideas or ask any final questions this evening?
I think Sadahan, you got a question. Right?
Teacher,
Yes, go ahead.
Yes, Sadahan, please go ahead.
Oh, wow. That's a wonderful image. Okay, I can see it a lot better now. Okay, can you explain what's happening in that picture?
a spacecraft came from the Earth and it sent two satellites. One satellite has a big telescope. The telescope, from the inside of the telescope, sends a big bomb to the asteroid to destroy a part of it, and it put another satellite to radio it, and the spacecraft hits the asteroid.
Wow, I think that's very smart. You have two different ways of moving it.
And that telescope shoots a bomb. Its name is LKB.
Wow, I love that all of you came up with names for your missions as well. That's great. Sometimes astronomers have a hard time coming up with what to name these things. So you really did cover everything there. That's great. Does anyone else have an idea you would like to share?
Yes, Sanuga.
Madam, look.
Wow, what's happening in yours? What's your plan?
Well, my plan is to push gravity, to push the asteroid out of orbit and into some other planet like Mars.
So to protect Earth, we're gonna let it crash into Mars instead. I guess that's okay because there's nobody living on Mars yet. So I think that'll protect Earth.
Excuse me.
Yes?
My future ambition is to be a UFO investigator, and I think there somehow some kind of organism like an extraterrestrial is hiding on us. So I think it's not a good idea to kill them in the planet.
I think one reason that idea though has some value is because we don't know for sure if there is life on Mars, right? But we do know that there's life on Earth. That's the only place that we know there is life. So if it was a choice between hitting something like Mars versus letting something hit Earth, I think most people on Earth would agree that we would rather protect the people on Earth. So if that's what it takes to keep us safe on Earth, then that might be the better answer. So I think all of your ideas are very good for different reasons. Does anyone else have an idea that you would like to share? I see many of you are still working on them. So I think what I will
got
do
any
is I will stay in
questions?
contact.
Yeah, if you got any questions, you may ask now. But if you all have any, plans, make sure that you write it down or draw a picture and you send it to us, and we'll make sure that we'll send it to Miss Jenny. That would be
Yes,
great.
I would love to see those. I know some of you are still working on them. So I know it's getting a little bit later there for all of you. So last chance if any of you have any final questions that you're wondering about before I go. And then of course you can always send the questions to your teacher
Excuse
and I can
me.
write back to you. Yes, one more question.
In my book, I wrote the topic as dark mission, and I wrote the dart one, and I wrote the asteroid and wrote about the dart mission as well.
Yeah, that's wonderful. So if you're interested in that DART mission, what you can do is keep paying attention. If you go to places like the NASA website or like this website where you can get that planetary defense badge, you can see the next mission, that Hera mission that will come along, and then you can actually pay attention and draw some pictures of that one as well.
Teacher, can you
Oh, we have a couple of people talking at once.
Guys, I think Tiniti has unmuted herself, so let's give her a chance because she didn't get to speak. Yes, Tiniti?
Ma'am, I would like to show you my plan. This is my plan.
That's a
if you
lovely
could-
illustration. Could you explain what's happening in your picture?
The machine comes out of the earth and it gets a lot of gravity from the earth, and when it mixes with the fire, the crane machine works and hold the asteroid and throws it millions and millions miles away from the earth, so it won't damage the earth anymore.
I think that's an excellent plan for defending Earth. And that's one that I hope that scientists will try something like that in the future, because we've never tried anything quite like that before. That's a great idea. Thank you for sharing that. Was there some?
Ma'am?
I think it's wonderful, and I love your picture as well. Was someone else wanting to share?
Demet, I think you had a question, right?
No. Yes, teacher, can you send me the link of that getting the life defense bench?
Oh yes, I will. As soon as this is over, I will send to your school the link so you can do the planetary defender quiz, as well as some other things like when are the meteor showers that you can see. There are all sorts of things. So even though we're about to wrap up this evening, there are lots of other ways you can stay involved and keep learning about these topics. I will send that along.
Excuse me, madam.
Yes.
How strong the big explosion that the spaceship hit to the asteroid? How big is the explosion?
Well, it was very big. If you remember from some of those pictures, that all of that dust and material from the surface of the asteroid went up flying. So there are scientists that are still studying this, even though we know it crashed into the asteroid. That's why there's another entire space mission going out to see what it looks like afterwards, because we know that it was a big impact. It sent lots of things out flying, but we don't know how big of a crater it left or how big of a mark it left on the asteroid. So that's something that we'll have to wait for in the future to see what that future space mission is able to see from how much of a piece of that asteroid it actually may have left a dent in it. So there's still some more things to learn in the future there.
Thank you.
Yeah, thank you for your question. Has everyone had a chance to share that wanted to share?
I think it's that for today. So if there is anything, Ms. Jenny, I will make sure that I share it with you, and I'll share your remarks with them during the class. And before we wind up, I just want to thank you, thank you very much for accepting the invitation. And plus you had, extra 30 minutes to explain that as well. So thank you very much for taking that time, because this presentation was really interesting. And I was interested as well as the students. They were asking a lot of questions. It shows that how engaging they were. So all thanks to your presentations and your hard work. It was very interesting. And I hope you could join us some other day and enlighten these kids about another topic related to astronomy. It would be really awesome.
Yeah, thank you so much. That would be great. I really enjoyed this time with you all. You all asked such fantastic questions, and I'm really excited for any of you that are still working on your plans for planetary defense and working on those drawings. I hope that I'll get to see how those turn out in the future. You have some really great ideas. So thank you all so much. I'm very glad that I could join you today.
You're most welcome.
Well, hopefully we will be able to talk in the future, and there are lots more things to be excited about in space. So I will send you some things you can look at later. And for now, I will say thank you again, and I will wish you a good evening.
Then bye.
Thank you. Bye.
Bye, teacher. Have a nice day.
Bye, Miss Jenny. Have a nice day.
Bye. Thank you. You as well. Goodbye.
Bye, teacher.
Guys, don't leave the session.